Hello, everybody. We're going to get started in just one moment. If you can't find a seat in here, this is being streamed to the other room where we had the B session. You're welcome to go over there if you can't find one here, but there's still a couple you can grab over here. Next turn. All right, we're going to go ahead and get started. Delighted to welcome everyone to the first keynote of the conference. We're thrilled to have Kristen Grauman as our first keynote speaker. As you can see, Kristen's going to be sharing with us talk she's titled Style and Influence from In the Wild Fashion Photos. But I'll give a quick introduction for anyone who doesn't know Kristen already. She currently is a professor of computer science at UT Austin and also a research scientist at Facebook AI Research. Kristen received her PhD from MIT in 2006 with Trevor Darrell, who I saw here. Trevor was one of my mentors as well. And Kristen is very well respected in the community, has received numerous honors. I was looking over her CV and she has pages and pages and pages of invited talks. So it's really an honor for her to be here talking with us. She also has many papers with over 1,000 citations. And we're thrilled to hear from her. Please give Kristen a warm welcome.
Great. Hi, everyone. Can you hear me okay? I want to make sure that you can hear me since I know we have a complex setup here.
We're good at the live part and hopefully on Zoom. People on Zoom here okay?
Yeah, Zoom is good.
All right. Good. Well, thank you for the intro. Thanks to all the chairs for inviting me to be part of this conference. I've been really looking forward to it, to the chance to share some of this work. And needless to say, would have loved to be there in person and at least feeling very excited for all of those of you who are. This is a huge step, so wonderful. The talk today is about our work relating computer vision and fashion. And so I'm going to talk about a number of our efforts centered around that theme. And just to be clear from the beginning, fashion, it can mean fancy clothes, it can mean shopping and commercialism and things, but it also just simply means what people wear. So when I say fashion, I really mean clothing and the clothing people choose to put together, put on their bodies and do whatever they're doing in daily life. So this is a rich and important signal for, understanding people, as we'll see in some of the work today. And generally, I think that computer vision and fashion are a great combination. The fashion problems can suggest new computer vision challenges, and computer vision capabilities can suggest new applications for the world of fashion. And I'm talking about things like the fact that businesses who have fashion as part of their merchandise can understand it better and its trends better with computer vision. The way a consumer shops with fine-grained search, if it's a visual search, can really be expanded tremendously. Artists, designers, creators can leverage tools of computer vision in order to do new things having to do with their designs. And finally, fashion is, as I said, really about people and what we wear. So understanding that in a computational manner has some exciting possibilities for our understanding of other things, including culture. And I'll be giving you examples that touch on a number of these things in the talk today. In fact, to kind of expand on this motivation, I wanted to highlight some of the really big challenges that exist in this realm and what specific questions it leads to for us computer vision researchers. So first, there's this question of style. And again, it's really a theme of the talk today. And you can see that style seems to be a challenging thing to capture, quite different than your traditional visual object categories or other categories. And so this leads to questions like, what defines a visual style? And what is fashionable? What is looking good? And how would you detect something like that in a photo? Now, other challenges that are quite, I think, motivating for this area of work. Again, I mentioned culture as being something revealed in our clothing. And I wanted to highlight that a little more detail, thinking about the timeline of just American history over the last, say, 100 years, where we see things like, the First World War leading to post-war simplicity in the clothing, or changes in economic factors like cheaper manufacturing that would lead people to have more access to very elegant looks that became more popular in 20s and into 30s. And then you have World War II leading to, again, a world event that changes how people tended to dress, and with more austerity, more simplicity. And then there's movements in our culture that change and expand items of clothing, like feminism, its rise leading to more denim being worn, particularly by women, or the anti-war movement leading to the famous hippie styles, bell bottoms and flowered prints. And then finally, elements in our culture like women entering in the workplace in greater numbers, leading to new style and trends. So isn't this fascinating how what we're doing in our world can play out in our clothing? And this can lead to great challenges for us vision and ML researchers to think about, how do you capture these relationships in a quantitative way? Final motivation about this space that I wanted to show is thinking of the movement of style and how styles that are popular around the world influence one another, move from city to city, place to place with certain gaps in time. And this is interesting as well to think about the research challenges, like how do you detect the movement of a style even once you know how to represent one? And what cities are influencing which other cities and with what pattern? So these are all elements that I think are quite inspiring for working in this space. And in my talk for the remainder today, I'm going to focus on our work all centered around learning style from in the wild or really web kind of photos, and looking at two main things. So the first thing in the talk is thinking about influence, the influence of fashion as observed between world events and cultural factors, like I motivated just now, as well as how cities relate to one another and how styles move around the world in both space and time. So that's the bulk of the talk today. And then the second thing I'll cover more briefly towards the end is to think about, more at the individual scale and thinking about how to perform recommendation for editing outfits to make them fashionable or more fashionable, and tailoring suggestions according to body shape. Okay, so that's the outline for where we're headed in the remainder of the talk. And I'm going to start with the cultural factors, but really for all of this, as I've mentioned, the foundations require some notion of style. So when we talk about style, here I'm showing you two sets of photos that I think exhibit two distinct types of style. And whether or not we can put names on them, there's something cohesive about these looks. Of course, again, it's not just categorizing garments. They aren't the same. The patterns and colors aren't even identical between any two of them, and yet they belong to a style. So this seems like a good challenge to start with. Will allow us to do some of the things I've already previewed. But how do you model style? It's kind of like it when you see it. So throughout the talks, the way we're going to be representing style is in terms of compositions of attributes. So even though these photos, say all the left ones that seem to be kind of preppy looking attire, even though they have dramatic differences on the whole, they nonetheless share some common elements, some foundations of color, shapes, localized textures, patterns that we could call visual attributes. And it's those attributes that emerge in different combinations with some regularity that seem to suggest a style. So distribution of attributes for those on the left, another one for those on the right, two different styles. So this is how we're going to model styles in all the examples I give you to follow. In particular, we take this approach where first we would detect attributes. Maybe they're trained in a supervised way, such as detecting butterfly collars, or maybe they're just mined from the data, like clustering region patches and things to find repeated elements. So we'll call that the first step, detecting attributes. Then we'll describe outfits by a distribution of those attributes. Just think of a histogram over those occurrences. And then finally, a style is some cluster or topic from those distributions. Okay, so what are those common distributions that keep happening? Each such latent distribution of the attributes, that's a style. Okay, so I just want to get that to start, because now in what follows, I'll be showing you, examples like this that we've discovered from data that are done in the way I just mentioned, where on the left, these are some styles we discovered from cataloged photos. The words are attributes that were detected in the photos, and then you can see the cohesive look, even though it's non-identical for each of these sets. And on the right, these are styles we discovered from a large-scale data set we'll talk about later called geostyle. And these are photos of people in everyday life, Instagram kind of photos that people have shared. You can see that there's some cohesion in these looks. These are the styles that we can now gain from internet photos. All right, so then let's talk about cultural factors driving what we wear. This is something we know occurs, and it's been documented and studied, trying to connect these influences. Here I'm showing you 3 other examples between what's happening in the world and what people wear in some kind of trend or style. Now, the goal we have is to be able to discover the world events and cultural factors that led to any given iconic style. And in our study here, we're going to do this across a century of clothing. So 100 years of photos, trying to understand when there's peaks and valleys of a given style and what's causing it, or what's influencing that change. How would you do it now? Well, you can do this with expertise in the area. So historians, anthropologists, people who could look at the patterns in world events and history and relate it to the clothing that's observed. Now, of course, this has concerns about scale and the expertise required, and even the potential that this might lead us to fixate on those that are most dominant and very clear, when we suspect there's quite a bit of more subtle relationships hiding in image data that we'd like to be able to reveal. So our goal is to make this an automated process, to use the data from images and some data about world events to unlock these connections, to really represent them in a computational way. How do we do that? So for this, we turn to a quantitative task, forecasting, that will allow us to ground a definition of influence. And influence, I mean, one thing being correlated or helping to reveal the next pattern for the other. So here's a cartoon example to explain how this will work. Suppose we have some visual style, like hippie style. Here I'm showing a green curve that is the popularity, suppose, over time of that trend, of that style. Now, observing just that history, you might tend to forecast that next in the future, its popularity might have a shape like this. However, what if we also knew that this world event or this cultural factor of the peace movement had a certain influential relationship on the hippie style? Say the bumps of the popularity over time have a certain lag. And maybe if we knew this was true, then having observed this history for the peace movement's popularity, we might make a different estimate about the future of the hippie style. And you can see, if we understood that influence, we might predict this spike. And if we didn't, we might predict a totally different shape. So this is what we're going to use to identify those factors from what I'm calling cultural factors that influence a given visual style trend. And what I just described in my picture here is quantifiable as what's called Granger causality. This is a metric that says the first variable is Granger causing the second if knowing the history of that first variable improves your prediction of the future for the second variable. So knowing the past of the other helps you better predict the future of the second. Okay, and that's what we saw happening in this example. So now we know that we could score pairs of these such curves, these frequency trends, using this to find out which ones are influential. Okay, and it's grounded in forecasting. So then how are we representing cultural factors? I haven't yet said that. And to this, we turn to news articles. So we think that news articles are a useful way to represent what's happening in the world. It's commenting on what's happening in the world. It's about the things that people are talking about, concerned about, following. And so what we did is take 100 million New York Times articles over 100 years of time. And from those articles, we looked at their word distributions and mined for textual topics. So this is good old text processing. Looking here, we use latent Dirichlet allocation to find text topics like you see here. These, think of them as clusters of the word distributions that happen in the different articles. So one might be about health insurance, one might end up being about Harry Potter, another one about the stock market. Now, knowing those latent factors or those textual topics, we can trace out these popularity curves over time for each of those in the blue. And then coming back to the visual topics, these are the styles I described earlier, where we've done some mining, in this case, over a century's worth of Flickr photos from a vintage group. So these are photos of people, often some magazine covers and kind of quintessential for their time period. So we've done style discovery over there, and now likewise we can have curves representing the popularity of each of these styles in the visual realm over time. These are the green curves. So now finally, we put these things together, compute Granger causality, I defined just a moment ago, and then we can just find out, which are the pairs of events and styles that have exhibited an influence relationship. And keep in mind, it doesn't mean they're correlated just positively with some lag. There can be inverse correlations. It just means that one's predictable better from knowing the other. All right, so lots of documents, lots of images come in over a century of time. And what comes out are these pairs saying these look like world events that are affecting these visual styles. So let's look at examples of what those are from our data. So here's one where in the gold box and the gold curve, you see the textual trend. This seems to be a topic about women. Note this peaks around the 19th Amendment and then places where women had greater engagement in sports. And then the visual topic is on the right. And this one has attributes like you see in the box there, jersey, faux suede, jacket, cover up, and visual style examples shown in these little pictures. And what we see is there seems to be an influence from the one to the other because it's capturing kind of workwear for women. Here's a second example, same format as before. Now you have the visual on the left and the textual on the right. And this is a textual topic having to do with Africa and some key African events. And the style has some interesting patterns, paisley, bird print, retro, embroidered floral, and like the examples you see here. So this is influential for the other. And the final third example I'll show, here's one where we have the World War peaks for events with this topic, and it seems to be a topic about war. And on the right, you see this utilitarian kind of style with blue and denim that was influenced by it. And of course, we found all this from the data exactly and without supervision, right? Just binding between the world events, what the clothing looks like, and discovering that there seem to be relationships here where one is a function of the other. So that we think is interesting, that kind of exploration. But we also wanted to get something definitive to say, how useful is knowing this relationship. So we tried two different tasks that I'll briefly describe. One is forecasting of styles. This one I've already kind of motivated. And so what we did is test whether we're better off making these forecasts with the understanding of the cultural factors versus without it. So here you have on the right a bunch of different models, and what differentiates them really is adding this ability to represent cultural factors, and that's our method in the bottom. And this is applied to two different data sets, in fact, one from the one I've described, vintage photos over 100 years, and another geostyle that we'll come to shortly. Okay, you can see it gives you a bump, so you're better able to forecast knowing about how things have been happening in the world. And similarly, the second task we attempted was photo timestamping, where we took pictures as input only, so just a photo at test time. And we would use this model we have relating world events to the visual topics to infer the textual topic that goes with the photo in order to then do a nearest neighbor in the embedding space to predict the year the photo was taken. And that's what I'm showing here. If you didn't have this ability, you have the visual only baseline, and these are accuracies. And if you add that cultural representation, the accuracy goes up quite a bit. And this makes sense. It's saying that once a model has a sense of history that goes with photos, then you give it a new photo and it has a better ability to place it in time. Okay, so those are two applications showing the value. And in general, what's exciting, I think, about this first step for us in this work is to be able to start drawing these kind of timelines that relate things that are happening in the world to how it plays out in everyday clothing. And this is a real timeline we computed from our model, where you're looking over the decades and you're seeing, in black, these world events and the text topics that came with them, or that reported about them, and then the styles that came later influenced by them as a result. And in short, now you've got a century of photos and the ability to understand at a deeper level than just how they look, why they look perhaps the way they do. Okay, so in influence so far, I've been talking about world events, economics, politics, the wars, everything that's happening. To what extent can we find out how that's shaping clothing trends? Now I want to keep talking about influence, but think about it in terms of movement of styles. And so what we're interested in is being able to say, hey, here's a style, like one of the ones we've discovered from our data, say it's one about flowery dresses, like shown on the left. And we want to know, how is that trend moving around the world? And in fact, how does any trend or any style tend to move? In what new spatial positions in the world, and with what speed? Now, if we knew about this style migration, if we knew it, we know it exists, but if we could actually model it computationally and have predictive models for it, this would allow us to do things like ask, is this style on the runway in Paris? How long will it take till I see it in New York? Or something that's popular now in Austin, is it going to reach later in Sydney, Australia, or is it not? Or where are the places it's most likely to travel? So these are kind of questions we could ask if we could model this. And so what I want to show you next is how we can take the unlabeled photos at scale across 44 different world cities and be able to capture these kind of propagation or migration patterns. And that collection of photos that we use, this is an existing data set from Cornell called GeoStyle, has some 7 million plus photos from Instagram, capturing 44 different cities in 3 recent years of time. And what I really like about this photo distribution is how in the wild it is. These are everyday photos people have taken, shared publicly, and they are capturing, what people on the ground are wearing. So it's not, a fashion show. This is just, what people wear from day to day. And furthermore, it's geographically diverse, hitting at least 44 different cities and at scale. So this is the data we'll use as the test bed to explore the idea I mentioned, or the problem I mentioned. Now, how do we address it? This actually can kind of build on what I was just showing for modeling influence between world events and visual styles. We're going to use the notion of influence, in fact, that Granger causality I introduced earlier. But in this case, what we want to know is which cities influence which other cities. So imagine you have N styles, like here's one at the bottom with these blue V-cut dresses. And you want to know for each of those styles, what's the propagation pattern? So which cities propagate to which other cities for that style? And then you want to know that for every single style you've discovered. So to find out, we take every pair of cities and score them for that style according to their Granger causality. So what'll happen is we'll find that for some cities, maybe knowing the style's pattern in Seoul helps you predict its future in Austin. And if so, we'll say that, that Seoul is Granger causing Austin style trend for that individual style. Now we can do this across all the styles, across all the cities. And again, we're going to ground the task in forecasting and use the detected Granger causal relationships between cities to decide which cities are inputs to the others when we do forecasting predictions for the future popularity of a given style. Okay, so related idea, I hope you can see the parallel to what I showed earlier, but now this is in the space of city to city migration of a style. So what happens when we do this? These are styles like the ones from the data that we've discovered. Again, it's attribute detection, then clustering here, it's a Gaussian mixture model to decide cluster, what are the different styles? These are 8 different instances of the discovered styles. And on the right, I'm showing a chart, a big chart full of errors for the forecasting task. And you see baselines that do either more naive kind of time series based prediction from the same data, or more elaborate models from the literature to do the visual forecasting. And then you have our influence-based approach on the bottom. And we are improving the state of the art for this benchmark. And we're getting this improvement by bringing in this influence relationship. So knowing, how things have moved from LA to Austin or any other pair of cities is getting us better ability to predict what the popularity of a trend will be there. Okay, so this is improving how well we can forecast. And that says that this model has done something useful. But all the same, we also want to know, what is found. So what are the relationships? What is influencing, who's influencing whom, or where is influencing where? So let me give you a little bit of a taste of that. Here are two big graphs, one for Europe on the left, another one for Asia on the right. And around the graph, you see different cities. And all these arcs in the graph are showing influence relationship as detected and quantified by our model. And so if you look at a given city, then you can look at all the influence it has on other cities across this circle. Now, these are complex relationships computed over all the styles that we've discovered. Let me zoom in on a few of them. On the left, here we can see Paris, where Paris is a city that's a multi-city influencer. So the outgoing arcs from Paris are many, and there's some incoming as well. And then on the right, you have Beijing, which is an influence receiver. So many different outside places are bringing in new styles to Beijing and coming out in those photos. Another thing we were interested in is what's the relative net influence of any given city in this data set? So what this chart is showing is if we sort the cities from left to right in terms of net influence, that's the difference between their exerted influence outgoing and their incoming influence received, then you get a sorting that looks like this. And what do we see here? So on the left, you have cities that are mostly influencing others. Seoul, Sydney, Buenos Aires, New York. So according to this data set, the influence is often outgoing, so there's high net influence. And that means there's some unique trends that they're coming with and that are propagating elsewhere. Then on the right side, you have cities that in this data are mostly influenced by others. So Cairo, Sofia, Los Angeles, and that means that they're taking in or absorbing and propagating the styles from some other places. And finally, you have cities here that are hubs, cities that seem to have a lot of influence coming in, but also a lot of influence going out. And that here in our data was London, Shanghai, Toronto, Seattle. So we get this global picture about who's influencing whom. And we can plot this on a map. Here, this is a heat map where the red hot colors are exerted influence is high and the cool colors is the exerted influence is low. And this gives you a visual, as a starting point to try and see, okay, how are styles moving? And then if we look at their aggregate motion, where are the centers of influence? Now, this is an interesting step for visualization. It comes with a couple caveats. Of course, there's gray parts in the map where we have no data. Furthermore, even for the parts where the images exist and there's such a data set of 7.7 million photos, there's still certain sampling biases you always get with internet photo collections, like, who are the people uploading, what are their demographics, ages, and this will steer, what kind of samples even get in the mix to start with. But all that said, I think this is a fun and interesting way to think about how to put numbers on what we know we can observe and practice, but now do this at scale and do it directly from large sets of data. Okay, so this was thinking about influence from city to city all around the world. And now I want to continue on a little bit further, thinking about influence, but now and thinking about the spatial patterns of style, but let's zoom in down a level. So rather than city to city, let's think of within a city. And this is a project that, in fact, appears in the main conference here at WACV. And the motivation is to look into the neighborhoods in an underground neighborhood map. So when I say underground, think of the underground guide of X. Like you have an underground guide of the culinary scene in some place, or you have an underground guide to a city, or underground guide to music, or underground guide of how to do X, Y, Z. So this is the language used to describe, kind of the insider's notion or the local's notion of how things work, as opposed to, say, some rigid traditional or textbook definition of how they work or what's good. All right, so we know underground guides exist. What we were after is to think about how fashion and clothing in a place could reveal some underground structure about that place. So what does fashion tell us about neighborhoods in a city? And we think it tells something, right? Something actually useful and dynamic, because the clothes people wear are a function of their interests, their style, and also their current activity. So as these three strips of three different styles show, what people are up to is going to affect what they're wearing. And you'll see that then as you look at a city and kind of what's the activity in different pockets of the city, or what are the professions that are common in different parts of the city. So can the clothing speak to us about an underground map? That was the goal. And so contrast that with a traditional map of a city that could break it down into nameable regions, like according to the geography, or the where the river is, where it's not, or where the city boundaries were before and where they are now. That's traditional maps. And here we're going to have an underground map that's really driven by the clothing people are wearing in day-to-day life. And in fact, the one I'm showing you on the right, that's an underground map computed by the model I'm about to describe a bit more. And you can see that there's different pockets of the city here that would reveal different activity. And this is for New York City. And it has to do with what people are up to, what's the business like there, and other factors like that. Okay, so underground maps from fashion. And let me say a little more now about how we've done this. We're again relying on the idea of discovering style from the web photos. So here are 7.7 million Instagram photos, and we've found attributes, we've clustered into styles, and now we do one more layer of grouping, which is at every position X on the map, we look at its distribution of styles. So of all the photos in some local radius, what are their styles? And now let's have a histogram over those. Okay, so you have a distribution of the styles present in that place, and do that at every single position densely in this map. Now, after doing that, you can cluster locations based on their style distribution. And that's what's showing on the right. And the output will give you a spatial segmentation of the map itself. And so what is a cluster in this? Well, it's a region where there's style coherence, meaning the distribution of styles that people wore were similar in that space. And then when we highlight a given style in these pop-outs, what we're showing is one of the dominant styles from that distribution for that location. Okay, so that's the lightning version of the approach that we took to compute these underground maps. And let's just look at some of them en masse. So we've done this for all the cities in the data set so that you can get kind of these side-by-sides between how the government would, or any tourist map often, or the non-underground tourist map would present the city to you, versus how the clothing in that space is telling you how to understand the different pockets of the city. And that's for cities here like New York, Seattle, Bangkok, Austin, Toronto. But let me highlight just a few, what's being found here in these neighborhoods. First, there's good prominence of clothing styles that neighborhoods that center around sports arenas. And this does come out really well from clothing, because you've got fans out there wearing the common colors or jerseys or other things. And so here's two of them each for London on the left and Madrid on the right. And I've outlined them with the red dotted circles, those neighborhoods. So those came out very saliently from our data. Another example, another application we were interested in is relating cities based on these underground neighborhoods. So you can imagine, saying, hey, what's the nightlife scene like my Chicago over here on the left? What's its counterpart in New York City? And this we're discovering by relating the clothing distributions from one discovered neighborhood to another. And the words you see at the top, those are just attributes. Okay, so you can relate cities, but we also discovered that, there's more we want from these. So we don't only want to know, what are the most similar looking neighborhoods based on clothing, but what are the analogical neighborhoods? What are analogies between neighborhoods? For example, to put words on it, what's the Bondi Beach of Sydney? What's the Bondi Beach for Sydney in New York City? What's its analogous neighborhood? And we show in the paper a way to compute this. It basically involves describing a neighborhood by its context with the rest of the city. So think of a relative representation of the style distribution relative to its own city, and then doing the same across neighborhoods in different cities, and now relating them according to the to what extent they satisfy an analogy. And so I'll just give you one example of that. Here you have Austin on the left, LA on the right. And these are one style for these two places in the neighborhood that were found to be analogy neighborhoods based on the activity and the clothing there relative to the rest of the city. But of course, being different places and different climates and folks, then you have still different clothing choices in the analogies that are drawn here. All right, so this sounds fun. I've shown you some, I think, interesting examples. But of course, just like before, we always have to come back and see, can we firmly evaluate what we're coming up with here? And for that purpose, we've developed in this work two benchmarks that are coming from kind of two plausible ground truths for your underground map. The first one on the left is from a source called Hood Maps, where people have crowdsourced their perceptions of the underground map for a number of different cities. Okay, so by hand, just looking at the map and their understanding of the place. So this is kind of how a local or how someone in the know would observe their own city. And then the second source we used was OpenStreetMaps, where we looked at business densities like banks, cafes, schools, where are these things across the city? And we found coherent neighborhoods based on that data as well. So that's two ways to find underground maps that don't have to do with clothing. But what we do is then hold up the maps we've computed against those to see how much they agree. So HM is for Hood Map, BD is for business density. And here you can see a swath of different baselines, things we did that clustered in different ways, used text rather than images, or used images but used them more naively. And what we found is that, compared to these baselines, and importantly, compared to admin, this row here in the middle, which is the traditional government ordinance kind of map, we're getting better alignment. Okay, so we're capturing, by some of these measures, we're getting agreement between how people perceive a city as underground neighborhoods and how we can discover those neighborhoods from the clothing we observe in public social media kind of photos. Okay, so far I've talked about how we find styles in web photos, how we start to understand the influence between events and propagation patterns around the world for style. And the shorter portion and the remainder of this talk, I want to kind of zoom in from this world stage and movement of styles and so on into more local kind of person-based and individual-based recommendation. And these are kind of problems that also have some natural applications for being able to help people find clothing or recommend clothing that might be of interest to them. And again, as I mentioned at the very beginning, there's two things I'm going to highlight briefly here. One is tweaking outfits for fashionability. That's next. And then the other one is about body shape. Okay, so when I say tweaking outfits, what we're after is trying to edit clothing. So traditional recommendation would say, here you go, this is what's good for you. Recommended garment or so on. What we want to do is a little bit different. We want to edit an outfit that exists. And you can take inspiration for this challenge by the words of Coco Chanel, who said famously, before you leave the house, look in the mirror and take one thing off. So what does that advice say to us? It's saying that there's some small changes you can make that may have a good, big impact on how your total outfit looks. So in particular, what we've proposed is to compute minimal edits that improve an outfit's fashionability. That's our goal. And my concept figure here shows three such examples that we'd love to be able to achieve, where you could take the image on the left for each of these pairs and suggest the image on the right, which makes a small change like removing a scarf or changing the cut of a top or even just tucking a shirt in, that have really good impact on the look. Now this, I should say, is going to be a challenging vision problem. You've got to be sure to model what are subtle visual differences, right? These aren't, becoming different categories. It's just subtle and maybe localized changes. And if you think about trying to train up a system to do this, you're faced with the fact that what's going to be your resource to teach your model what pairs of slightly different things are better achieving more fashionability. So there's some of the challenge you face trying to tackle this. But to the application, we think it's pretty strong. So the model I'm about to show you is called Fashion++, because we're pushing up fashionability just a bit. And it's going to be, you can imagine applications where someone is dressed in a certain way, and looks to their system who says, yeah, pretty good, but we can make it just a bit better if you make this change. Okay, that would be the output of Fashion++, both the new look as shown on the right, and even a suggestion of a garment that would achieve that look. And that's what our model will produce. So then finally, how do we do this? The model that we presented for Fashion++ is based on image generation pipeline. So you have an image as input, you have an image as output. So there's gonna be some editing to that image that the brains of the system will do. And the system, this network has two parts. We're factoring according to shape and texture. So for the texture, for every body part or every region detected in the photo, there will be a texture code, and each of those texture codes are going to be improved to be a new latent code, and then propagated to texturize the different regions in the image for the different garments. And this is achieved through a conditional generative adversarial network, conditioning on these shapes. Okay, so I'll say in a moment about the edit itself. That's the texture, and then the shape, we use a variational autoencoder to model in some low-D embeddings for the shape regions, and then again, improve those to be improved ++ shape regions, and then map them back together with the texture to compute the output. So now the central point, this F++ function in the middle, this is a discriminative model for fashionability. And so when we compute the edited codes, T++ or S++ for texture and shape, we are doing so by taking small steps along the gradient for this discriminative model of fashionability. So you have underneath a model, a classifier that understands how to decide if something's fashionable or not. And this is what we're able to move along in that direction to change a bit towards the fashionability direction. Now, how do you train that model? I mentioned that actually is one of the key challenges. For time, I won't go into detail, but what we were able to do is bootstrap negative examples by taking all positives of fashionable web photos, people wearing their clothes, and then kind of altering them to garment by garment to make some near negatives, and then training this fashionability model. Okay, so you now have Fashion++, you come in with the image, you improve it, you suggest an improvement as an image. And here I'm going to go show you a sample of 5 at once, where here you have the input images at the top. Pick one that you want to, study, and I'm going to animate it, and you'll see what Fashion++ suggests. So before and after, and before and after. And you can see some things changing, like the third woman, her shirt became pink rather than white. The second woman, her pants had been, I guess, white, and now they became light blue and a little bit more fitted. And what our model can do, aside from showing you this, suggestion, is to also fetch the garments that would achieve the suggested look, like the pink shirt for the third example, or the light blue pants for the second one. And that's just done by visual matching once we have that predicted output photo. Okay, another and final set of examples I'll show here. These I think are quite fun because here we control to change for the shape only. So if you want to say, hey, let's not like undo all the clothing, but let's just change a little bit their fit or how they're presented. And so here's before and here's after, before and after. So for example, you can see the third one, her shirt was out, and the model as its improvement just suggests to tuck the shirt in to give a better look. And that's possibly because of the factored model I described. So evaluating this model, what we looked at was both ground truth data, which we have on the left, that we can quantify how well we're doing against what should be the fashionable edit. And then a human subject study where we just showed people the results and asked them to judge how well the two things are being satisfied. One, in the vertical axis, the fashion improvement, and 2, on the horizontal axis, how similar things still look. And that second one's important because if we only say, let's make things more fashionable, a model could just be like, here's the most fashionable outfit ever, I'll always give it back. But what our job is to edit, right? To just take something and make a small change so it remains really close, but it does look better. So you have to balance both of these criteria. And so that's what you see in these charts. You want to be in the left top of the chart. The red dots are our model. The others are doing things like solving for only one of those, or optimizing for only one of those, or doing some random edits. And we can see that there's progress made and moving towards a good balance of fashionability without changing things too much. Okay, and that was, a machine generated suggestion of a change to an outfit. That's all what Fashion Plus Plus seeks to do. I wanted to pause with a plug for a related but different challenge that comes with both a new data set and benchmark for iterative fashion search. And this is the Fashion IQ project, where now instead of the machine just giving you the edits, you, the user, can talk to the machine about, okay, yeah, I see that dress, but the one I want should be more striped and have more coverage on the neck. And then now there's data to learn how to do that and also to judge performance on this very task. And if you're interested, check out Fashion IQ from CVPR this year. All right, so final couple minutes of this talk, I wanted to then touch on another aspect of recommendation that I think is understudied and that we've started to dive into, and that is to understand body shape. So when we recommend clothes, if you have a great recommendation system, it's often going to be caring about, some profile of the user's taste, things they've clicked on before, or things they've indicated they like. But a huge part of clothing and its success on people is fit. And people don't have the same shape. So recommendation really has to pay attention to body shape. And good news, body shape is evident, can be evident in photos, and there should be a way to account for this because it's a visual factor. So our goal in this last piece of work is to recommend clothing that's sensitive to body shape. Okay, taking into account that we're all shaped differently and things are going to look or feel better on us, depending on what they are. Right. Now, trying to tackle this problem, part of it is a data challenge, because great data sets in literature are really diverse in certain ways, but not generally in terms of body shape. For example, Deep Fashion, a wonderful data set for understanding fashion, tends to be biased nonetheless towards fashion model or fashionista kind of people that are tall, thin, more than the average population. And so one of our first steps was to generate or collect a data set that has people of more variety of shapes, covering more of the population average, like you see at the top. Okay, and how did we get it? We used this Bird's Nest website, which is really cool. It has photos from a catalog where the models themselves are of different body shapes, and they wear certain parts of the catalog inventory. So you can see the garments on people whom they most flatter, and those people are of different body shapes. So we use this data to then discover, we can treat this as sort of free supervision, saying the models who wore the clothes, those clothes flatter them, and that's our assumption. And so now we can kind of aggregate that across related body shapes. So now you have positive instances saying, hey, these clothes flattered well these body shapes, and similarly these did not. So we can generate negatives in a similar way. And now we can learn an embedding that we call VIBE, or visual body aware embedding, that maps together in one space both clothing and body shapes. The clothing as represented by attributes and by the pictures of the clothes, and the body is represented by measurements if we have them, but also just the inferred 3D body shape parameters from an off-the-shelf simple model. And we bring these two together and say two things. One, when we learn this embedding, it has to be the case that bodies are close to their flattering clothing, and it has to be the case that bodies are close to similar bodies. And here I mean shape. Okay, so you learn this embedding and it's cross-modal, so that once you've trained for these objectives, you come in with, say, a new body, and you find out what are the clothing garments that are most flattering for it. Or you come in with a new garment, maybe you've designed a new garment, and then you map in this space and find the body shapes that are most, it's going to most flatter. All right, so that was a brief version of this VIBE model. It's here's examples of what it suggests. So for the woman on the left, it highly recommends the garments on the top and low recommendation for those on the bottom. So it's looking for certain cuts and patterns and shapes that really flatter her curve. Second example, a different body shape, a more petite subject on the left, and it's suggesting different things for the top, things with more volume, with embroidery and ruffles that you see on the top, compared to the negative or the non-recommended ones on the bottom. Okay, and of course, we've quantified this against some ground truth compared to models that are body agnostic, which is really all that we're aware of for clothing recommendation today, to also a user study on the right where we ask people to pick which they'd prefer and see if for a given subject and see if it aligns with what our model predicts. Okay. All right, so I'm going to close the talk here. This has been a summary of the things we're up to, trying to understand fashion and clothing at scale from everyday photos. And we've done this to allow studying influence of world events and how people choose clothes, as well as to understand or make improvements for forecasting tasks and recommendation tasks that match people to clothing that they may like. And all this work is with the amazing collaborators I'm listing here: Kimberly, Ziad, Utkarsh, Kavita, Tamara, and under each of these co-authors, I'm showing the parts of the work that I described today that they were involved in. And that's it for me. Thanks so much for your attention, and I'd be really happy to have your comments or questions.
Hi.
Hello.
In the style forecasting, in which like each particular style is being influenced by a particular event in history or some cultural influences, how are you seeing what the future styles might be with respect to the present events? For example, the pandemic has caused a rise in people wearing masks and all this. Do you see a cultural shift in the styles that people wear simultaneously right now? And second question is, how do you differentiate between, like, people wear different clothes, but how do you classify as one as more stylish than the other? Is it like a picture in Instagram, if it is getting more likes, that will be quantified as something more stylish, or is it like more people wearing the same kind of clothes being considered as more stylish? Because if like a celebrity might get a huge likes, but that cloth will be a very unique, which most people won't be wearing. And a kind of clothes that common people are wearing will be much huger in number, but it might not be something that can garner likes.
Great. Yeah, no, thanks for those questions. Let me comment on both of them. So the first one, so in the first work about the century of fashion, we have a set of styles that is fixed. So meaning it's discovered from the data, it's uniform across the century, and it'll just be the case that sometimes they're absent, so this is just not exhibited in this decade, but then it's present elsewise. And so we have a vocabulary of styles, and that's what it is. But your example makes an important point, which is, even, that's handling the fact that things could be absent, like there's no masks. Well, not at this stage they are now, back in say 1930, but that would be okay in our model. But I think it's very interesting to also further model the evolution of a style, and in fact, the slow evolution. So masks are very binary. It's like they weren't wearing them or now they're wearing them, but other styles kind of gradually evolve themselves. So it's like changing a bit over time. And that's I didn't talk about that work, but that's something that we've been also investigating, how to model that evolution. The other question is about, how do you get ground truth for fashionability? And this is such an important question. You're right. Some ideas in the literature have pointed to, using likes, but it would have certain things that are good and certain things that are bad, as you kind of summarized. What we do is different. What we did to train the fashionability model is to suppose we just have positive instances. So we go online, we're collecting these photos of just what people are wearing. We say, well, this is how people put clothes together. This counts as fashionable, and some of the data sets available today, like Fashion 10K, these are from more like fashionista types. So you say, okay, this is fashionable. And then we created negatives by doing some swaps of garments. So imagine taking this one true, it's a positive, it's fashionable, but now swap the shorts of that photo with the shorts from some other photo that's far away. And now you've kind of destroyed it a little bit. And we'd say this is a negative. And that's how we managed to train this data, with only having to suppose we have positives that are labeled, or implicitly that all the fashionable photos are positive.
So basically the negatives are unrealistic styles, like which doesn't actually exist in the real world.
Well, yeah, they're corrupted photos, right? And by the way, we don't do it in the pixel space, we do it in the latent feature space for those garments. And so it's as if you change one garment, but changed it right from a more distant outfit. That's what is a negative.
Also, since these are mostly from internet, like there will be a bias in which like the number of people who are actually using the internet or like using Instagram per se, and a whole mass of people who doesn't use.
Yep, the audio has
And
gone out, but
parent in
I
the
think,
yeah.
yeah, that's right. And I did mention this, I agree. It's like for any internet photo kind of work, and particularly say maybe clothing, things surrounding people, right? This bias of demographics just implicit in who's putting photos where, you're going to feel that in your data set. So yeah, definitely conscious of this, like to the limits of what photos are there. This is what we can learn. I do think what's attractive about these kind of photos though, it particularly, you know, the Cornell geostyle data set is that they are every day, they're dense in a space, and every day, just meaning, you know, what people took and shared as opposed to fashion magazine photos. And this is an important step we're able to take by using this kind of large data set.
Thank you.
So we've got a couple of offline questions. One was posted on the virtual platform yesterday and says, how can we tackle the subjectivity in fashion while attempting solutions for recommendations for mix and match wardrobes, classification of clothing images with respect to fashion styles, occasions like party wear, elegant, casual, office wear. The algorithms are entirely dependent on data biases, while tagging and interpretation of results vary with personal, cultural, or geographic biases.
Sorry, I'm afraid I didn't hear the question very well. Could you recap a bit for me? It was kind of in and out a little bit.
So I just dropped it in the chat as well, if that helps.
Okay, yeah, sure. Subjectivity in fashion, okay. Yeah, no, I think this is you know, a fair comment for sure. It relates to what the previous one too, you know, that we're working in a space that's does have elements that are highly subjective, and yet we, for especially say the recommendation side, you really care about that subjectivity. I mean, you're trying to meet the perceived preferences, say, of a person. So I think this is a challenge. It's a challenge in the research development because of the major work required to do systematic evaluation. So you can build it, you can feel like results are good, but to zero in on quantitative results, in our experience, is always taking a lot of, you know, going an extra mile, whether that's from user studies or from being a little bit creative about how to obtain ground truth. For example, you know, when we did the underground maps, you know, finding these benchmarks like hood maps was a real score, so that we had something firm, you know, not you know, not that you couldn't have other sources, and we've tried to, but, you know, something firm to hold up against what you're discovering. And I think in every which way, in every part of the work I showed you today, the evaluation always is kind of a very thoughtful and challenging part of the process. But this is what we need to do to not shy away from the task, you know, and allowing for the fact that there is some subjectivity, and there's going to be, you know, even evolution of the fashions that we're trying to model. But yeah, I think this is definitely something to be conscious of.
Great. One more was, did you find anything neat in explicit religious garb across time or location? Explicit like Muslim hijab and burqa, Jewish yarmulke and talit, Buddhist kasaya, Catholic rosary, etc.
No, but doesn't mean it wasn't. Doesn't mean necessarily wasn't there. But I don't recall seeing any example that popped out that we analyzed for that.
So any questions from the live audience here? We've got a couple. If you want to come up here to the mic, that's perfect.
Do I need to? Oh, sorry. Hi, I loved your presentation. I just have a quick question. So I noticed that most of the models and fashions that you used were female specific. And, you know, as we kind of move into a more socially and fashion-wise gender androgynous zone, I'm wondering how you think that these models and methods would translate to, you know, less female specific body types and clothing.
Yeah, definitely. Right. So some of, across the talk today, there was probably 4 or 5 data sets in the mix, and some are very female centric. Others are not exclusively so. But for the body shape specific, you're right that to my knowledge, all of the 60 or 70 models who are in that data set are female. So this is a data issue. For one thing, I don't expect that we would, that one would need to start over in terms of the models, because there's really the models that we developed, say for the vibe, the shape modeling part of it are not female specific in a certain way, right? So I think, remains to be seen, but it's definitely a data question, data issue to be able to demonstrate that if that's the case. Yeah.
Other question. All right, thank you for the very thorough analysis. I was just wondering about the beginning of the presentation. You're talking about defining the list of cultural trends that you're using to do the pairing process. I wonder, how did you work around the interdependency between cultural trends? For example, one thing that you said about the using the stock market and the political trends as distinct, different trends, but there is a strong correlation between those attributes, if you will. Does that make sense to you?
Yeah, I think you're saying that, you have a list of these cultural factors, which are these text topics, but they themselves have partial overlap or relationships between them, right?
Yes, exactly. So how do you deal with the interdependency between those trends, assuming that you're working with supposedly the model that you're using? So you didn't talk about it specifically, but I'm assuming it's a classification model.
So yeah, so this is handled in the way that so the model to decide if they're influential is this Granger causality computation that we do for every pair. So like every textual topic against every visual topic, and that's what yields this list of go, no go in terms of pairs that have strong influence or not. And so it can be the case that you have, say, A and B are 2 different text topics that are nonetheless, related. And what you'll expect to see then is that A and B may both have Granger causal relationships with visual style X, and that's fine. And so the more those text topics have redundancy, if they do, it's what'll pop out is that they have similar influence relationships on similar sets of visual styles.
So what about the relationship between A and B? How can you come up with that? I guess what I'm asking is, if you found that A and B both have an influence over this particular trend, over this fashion trend, now can you start inferring a relationship between A and B, and in what capacity?
Yeah. So I mean, the relationship in terms of their similarity, yes, we could certainly compute that. In terms of, they'll have some distribution over these the word variables, and so you could measure how close any 2 are. So that we could do, and I can see where I think I see, the interest in it, because you could, come back and look at maybe even over segmentation in the sense of the topic space on the world events, but you want to know more a mass, maybe even a hierarchy, right, of what are the related topics and their influences. So a topic similarity, I see for sure. What I don't know, and maybe be glad to hear your thoughts offline too, it's maybe you're thinking the influence, of course you can have influence between the world events as well, and how would that benefit either our task or change the task? That's something else to consider.
That's exactly correct. There is a strong dependencies between the cultural trends, not only in one country, but across the world. So that's, I don't want to take a lot of time, but I was just wondering, how did you think about this when you started defining the list of attributes to kind of define what culture is? Does that make sense?
Yeah. And we didn't model those influences, but we also didn't define the attributes because the words over there are just the raw words from the articles. But yeah, it sounds like something to give some good thought.
All right, thank you.
Thanks.
I very much enjoyed the talk, and I was curious if there's any evidence in this Granger causality for sort of the expectation that things move faster with sort of nationalized television and social media across the globe. Do things spread faster? Is there more homogeneity because of globalized media?
Yeah. What a great thing to check. So I don't have numbers or that analysis, but we could do this, right? We could look and see kind of density of the influences and the lag parameters, because you're always looking at different lags in time to decide if there's a Granger causal tie there. So wouldn't it's a great idea to kind of look at what that distribution is like, and is it narrowing? You know, is it flatter? Yeah, the world connectivity and the time gaps, do they get shorter? That would be really something fun to try and pull out of the data that we have, and see if that hypothesis plays out. I mean, whether it plays out with this data or not. Yeah.
Hey, Kristen, this was great. I was wondering how fine can you get in your influence checking? For example, can you start seeing particular things, saying that a certain kind of color comes from one source versus the length of the skirt comes from another source, and so on? You know, people in fashion probably like they talk about copying or homage or things like that. So can you study this with your frameworks? And then kind of related, if you have multiple influences, which is probably what's been happening in the last 10 or 20 years, should you be, instead of just looking at this series of Granger causalities, should you start looking at this in the sense of a graph analysis, maybe?
Mm-hmm. Yeah, okay, so on the first one, by a source, do you mean like a news event, or like to attribute the visual change to a certain event, or?
No, the first one is mostly more about, if you think about just high fashion, you can say that designer X was influenced by this particular thing from designer Y and this particular thing from designer Z.
Yeah.
So can these things be picked automatically at this point?
Yeah, so yeah, actually, I didn't present this today, but we did a study like you described, and this is in Ziad's multimedia paper. And we took designers and we, you know, kind of did the process just as you saw, but did it in the way you just described, which is to say, okay, it was Calvin Klein, and I'm not going to enumerate a good set of designers here. You know, is this designer A influencing this one, or, you know, and how are these trends traveling between designers or fashion?
But that's what I was saying. Can this be generalized now to basically fashion in large scale in population, which is what you've been talking about in this talk?
Yeah. So right, so it's applicable there too, and we do have results for that, and we could show kind of some, you know, the analogous things with these webs of influence, and then the forecasting improvement and so on. The other question you had was about, you know, I think was saying, you know, can we go beyond pairwise relationships and model this with a richer connectivity, like a graph structure, maybe? And I think that we haven't done it, but I think it makes a lot of sense. We're making a certain limitation in the modeling side by treating pairs, but you could think about doing this just more generally, yeah, between the different variables with a graph, but remains to be done.
Okay, thanks.
Thank you very much, Kristen, for sharing your work with us. Let's give Kristen one more round of applause. There were a couple additional questions, and encourage those individuals to reach out to Kristen online or on the virtual platform. We'll make sure this question gets. Thank you again, Kristen.
Sounds good. Thank you very much.